Okay, so we have some definitions already written for us here. Skew lines are two lines that do not intersect and are not parallel. Those appear when we have 3D objects. Okay, because if it's only 2D, they're going to either be parallel or eventually intersect. And so if I had a box here, or a cube, the skew lines would be like maybe on the top going this way, and then on the bottom going this way. They're on complete separate planes, and so they're never going to intersect. You don't have to draw it if you don't want to, but so if it's easier to see like an actual 3D object like this, so like my skew lines would be across the top here and across the bottom here. So they're never going to touch each other and they're parallel. So those are what we call skew lines. Parallel planes are just planes that never intersect. It's pretty easy. Transversal is a line that cuts across two or more lines. Okay, so a lot of what we're doing today deals with transversals. And so it looks like this. This line's called a transversal. So if we look on here, so line is skew to FG. So here's our FG line. Can anyone find a line that would not be parallel and never touch FG? Yeah, so CH. ED is what I heard. And I thought I heard something else. Was there another one? DC. But DC, I know it's on a lower plane, but it could be counted parallel because we have that. EC, if we're going with theoretical lines, not ones drawn here. The BC, definitely, yep. And what other one? AD. And I think that's all of them that we have there. Alright, lines perpendicular to FG. Can you find some perpendicular lines? Do we remember what perpendicular means?
AC, no, perpendicular, like this, right?
Perpendicular means right angle.
Oh, I said it's parallel, sorry.
Oh, AF?
Yeah, AF, and how do we know that's a right angle?
Because it has a box in the corner.
Yeah, so if it doesn't have the box or doesn't give you definition, we can't count it. So AF and BG? Alright, and now the parallel ones. Which ones are parallel?
DC, EH,
DC. What was your second one you said? EH? And AB. Alright, so now plane parallel to FGH. Yeah, ABC. Okay, so plane, remember, is when we now have that flat surface, so FGH means we're talking about that trapezoid end of the box, and so ABC. Or you could label it DAB, you could label it whatever you wanted.
Wait, so if this parallel, you just like that or one of them DC is parallel to AB?
Yeah. For the lines, yeah. So then this one came to plane, which is 3 letters, and so we have to, the whole surface ABCD is parallel to FGHE, but we label planes with just 3 letters. All right, here's these class. All right, thank you. Okay, here's the new vocab you guys have to learn. They're pretty easy, but you just have to know what these are. So corresponding angles have corresponding positions. So angles 2 and 6 here, they're both above the lines that the transversal is crossing, and they're to the right side of the transversal. Pretty easy, right? So 2 and 6 are corresponding angles. So you turn to the person next to you and say, corresponding means same position.
Corresponding means same position.
Or technically corresponding positions. All right, what does the word alternate mean?
Switch.
Yeah, alternate or opposite sides. So alternate means opposite sides of transversal. Okay, and interior just means in between the two lines, the transversals crossing. So interior would always be in the middle, versus this next one, exterior, is outside of those lines. So alternate interior angles, alternate exterior angles, they're just on opposite sides of the transversal and either inside the two lines, outside the two lines. Yes?
Does it matter if the 4 would be like on alternate interior angles? Would it matter if the 4 was on the left side and the 5 was on the right side?
No, those would still be alternate interior. And we'll have a drawing that we label these in just a minute. Okay, consecutive interior angles is when they're inside and on the same side. So consecutive means like beside each other. These are also sometimes called same side interior. You'll see it sometimes both ways, consecutive interior or same side interior. So once you have that, flip to the next page.
Are we almost done with notes?
It goes through page 3, so I wouldn't say almost done, but they aren't real long today. Okay, who thinks you could label some of these on your own?
Debatable.
Debatable?
Yeah.
I can see quite a few hands up. All right, so let's take. Okay. So our next one is, this is called corresponding angles postulate. When you see a postulate, what do you think we're going to do with it later?
Postulate it.
Adam.
Prove something maybe?
No.
Oh.
Most people find the proofs we do in this chapter a little easier than last chapter. I know last chapter was hard. Okay? I know. Alright guys, so voices back off. The postulate is just, if two parallel lines are cut by a transversal, then the pairs of corresponding angles are congruent. That's our theorem that we have based off of. And so our hypothesis would be, if we have this, and these little symbols mean they're parallel. Did you guys know that yet, or is that new?
That's new.
Okay. So when we have these arrows kind of like in the midline, going the same direction, that means they're parallel. Or if we had a statement like line P is parallel, the two up and down lines, to line Q. Have you seen that statement before?
Yes.
Okay, so you've seen it this way. Sometimes it's drawn that way. Sometimes it's just drawn with arrows in the middle of the lines pointing the same direction. But those are the symbols let us know it's parallel. And so if these lines are parallel, then corresponding angles are congruent. So that means 1 and 3, 2 and 4, 5 and 7, 6 and 8. All our corresponding angles are congruent. Can you guys also, in geometry we can't go by the way it's drawn because sometimes things aren't drawn to scale, but it can give us a hint. If we just look at what's here, we know they're all adding up to a straight line. 1 and 3 are both obtuse angles, so we know they can't add up to a straight line. They're going to be congruent instead. 2 and 4 are both acute angles. So if you can see it that way, that can just be the hint for which angles are congruent and which angles are supplementary. All angles, if we have parallel lines like this, every single angle pair we can look at, they'll either be congruent, so exactly the same measure, or supplementary, where they add up to 180. And so, looking at that, corresponding angles, are they congruent or supplementary? We just defined it. Corresponding angles, are they congruent or supplementary? Congruent, right? What does congruent mean? Yeah, no, it means they're the same. They equal each other. And so our corresponding angles, if I start with angle 1, oh, I should draw my sticks again. All right.
Yay!
Okay, angle 1, and my question is, which angle is corresponding with angle 1? And I drew desk 2.
I'll go.
But you're not desk 2.
Oh.
So, Aylin, which one's corresponding to 1? What's no way?
Wait, who did you pick?
She's looking.
Oh.
Okay, alternate exterior. If we look at our alternate exterior, so like starting with angle 1 and angle 8, what do you think those are congruent, or do you think they are supplementary?
They're congruent.
I think they're congruent. Why do you think they're congruent?
They are both obtuse.
Yeah, and you were correct. So alternate exterior, they're congruent. How about alternate interior? What do you think about those? Yeah, so if we have like angle 3 and angle 6.
The alternates are congruent.
Yeah, those are congruent also. And if we have our same side or our consecutive interior, so if I start with angle 4, what's my consecutive interior with angle 4? Angle 6, right? What do you think, congruent or supplementary? Supplementary. How do we know they're supplementary?
Because they're on like.
So supplementary means they add to 180, but what's my clue about that? Yeah, if we were to merge them, they'd look like a linear pair, right? And then I could see this is an acute angle, this is an obtuse angle. And so those are the hints that can help you remember if you forget these when you're doing your work. All right, and then same side exterior, so that'd be like 117. What'd you say about that? Oh my goodness, I did that wrong. Supplementary or congruent? Supplementary again, right? Okay, so every problem that we solve with these, we determine the angle pair, we decide if they're congruent or add up to 180, solve for x, plug x back into the angle. 4 really easy steps, right? Okay, so flip over to our last page of notes for today. Let's actually solve some problems. No, this is not hard. Don't say that.
You know this stuff.
Okay. Alright, you ready for me to explain it so it's a little easier than just looking at the page?
No.
Okay. So alright, class. I can continue when everyone's quiet and looking up here. Okay, so here first we're going to look at the angles. So they gave me 115 here, they gave me y here. What type of angle pair is that?
Linear.
Yeah. No, what? Linear. Congruent.
But of our new names, corresponding, there you go.
Oh, same it.
Okay, so it's corresponding. If it's corresponding, are they congruent or supplementary?
Congruent.
And so if they're congruent, what does y equal? See how easy that is?
That's all we know.
And you guys groaned over that?
Wait, that's all we know.
This one just said find the angle measure, so if it just asked you to find it, you could just recognize 115. A lot of problems ask you label and then find it. Okay, so 7 we're going to set up the same way, except there is going to be a little bit of math to solve. Okay, so what type of angles are these? What type of pair?
No, corresponding.
Corresponding. And so corresponding equal each other or add up to 180?
Congruent.
Congruent. And so we just set them to equal each other. So 4a equals 2a plus 50. And then we just solve. Can you guys see this color pen okay?
Yes.
Do I need to switch to a darker one in the back? I heard a no, so I'll switch. So minus 2a from both sides. 2a equals 50. A equals 25. Am I finished?
No.
No. Which angle did it ask me for?
Oh.
Yeah.
BYX.
So yeah, just do 4 times 25, which is 100.
Oh, you gotta plug it back in.
If I had plugged it into WZY, would I have gotten the same answer? Yes, because they're congruent, so that's going to be the same. Okay, problem 8. What type of angles? What type of
Alternate
pair?
interior.
Alternate interior.
Let's go.
Ooh-wee.
You earn a cookie.
Okay, congruent or supplementary?
Oh. Congruent.
Congruent. Mm-hmm.
So they can equal the same thing.
Yep. So what's my answer?
That's 16.
Mm-hmm. And is that the angle that they asked me for?
Yes.
ABC? Yes. All right, number 9. What type of angle pair do we have?
The first one.
First one.
Same side interior.
Wait.
Same side interior, right? So are they corresponding, congruent or supplementary? Supplementary. So how do I set up my equation for this?
Equal 180.
Mm-hmm.
Yes.
All right. And then I combine like terms. And so what does x equal?
Equals 6.
X equals 6, right? Okay, and then EFG is the one it asks me for, so it asks me for the 17x. So what's 6 times 17?
Or 17 times 6.
17 times
I got
6?
this.
120 minus 18.
102. Yeah, I heard someone say 102.
102.
So you guys are good. You didn't even get pick up calculators today. Mental math, yep. All right, the next one, which is not numbered for us. What type of angle pair is that one?
Corresponding.
No.
Yes.
Same side X.
Because corresponding we'd have to have one on the inside here. So this is our same side or exterior. Congruent or supplementary?
Sub.
Yeah.
Supplementary. And so 4x plus 52 equals 180. What does that come out to when you solve it? Do you guys want me to show the steps to solve?
No, it's mine.
All right, and then what is my answer? Well, that's true, but we assume that we're supposed to find the whole missing angle if it doesn't ask us a question.
So 32 times 4.
32 times 4, 128.
That's what I was still figuring out.
Okay, the next one is a little shows something else, because here is the 2x minus 3 and the 153. Is that any angle pair that we know we can solve with?
Alternate.
They're alternate, but one's exterior, one's interior. So that's not a specific angle pair. But if this is 2x minus 3, what is this inside one here?
2x minus 3.
Yeah, so that's also 2x minus 3, because I know this thing. If this is 153, what's the top here?
153.
And so I can very easily see, even though that's not a specific angle pair, I can still set up my linear pair with these, or my same side interior if I copy it over here. So when we're working with these, you're still, any angle pair there, your option's still going to come out to either supplementary or congruent. And so I still set it up as my 2x minus 3 plus 153 equals 180. You guys want to race me to solve it?
No.
Not yet. Ready, set.
All right.
Wait, don't go yet.
Ready, set, go.
You said no go yet?
Oh, it's X equals 15.
All right, Aaron got it.
30. 627.
Yeah. All right, x equals 15, and then the angle is 27. Okay, I heard an I don't understand. Do you want me to go through the solve? No, I have the answer key with all the steps written out for me. Okay,
I solved it.
I'll upload it to
I
Canvas.
solved it for my test.
No, not on the test. Okay, so 150 was when I combined these, and then you just subtract 150 to get 2x equals 30, and then that's how I got x equals 15. Okay, so these last two are a little different. They say to plug x and y back in and decide if the lines are parallel. And so these problems, first of all, what's different about these last two?
They are bigger. The pictures have words. The lines a little bit cut.
Oh wait, there's pairs, there's equation pairs. I forgot what they're called.
There's equations. Do we have more than one variable?
Yes, that's what.
Okay, so every lesson we do, you're in pre-AP, there's going to be some problems that just have a few more steps. So here we have to use these equations and solve by substitution. Once we get our answers, we plug it in and say, hey, are these lines parallel or not? So how do we solve by substitution?
You get one variable by itself.
So here it's x minus y equals 3. So I'm going to just add y to get x equals 3 plus y. So if I add y to both sides, that's pretty easy, right?
Sure.
Okay. So some of you may, especially if you were in regular algebra 1 last year, you guys didn't spend long on this. So when I'm solving by, okay guys, one talker. When I'm solving by substitution, that means I have to first solve for one of my variables. So I need x by itself, so I do plus y. So then it cancels out and I have x equals 3 plus y. Now I take this expression and just plug it into this equation. So I have 6 parentheses 3 plus y. Because I replaced x with the 3 plus y, minus 4y equals 20. What do I do next? Solve it. Yeah.
18 plus 6y plus 4y.
Alright, what's next?
Plus 2y. Combine like terms.
Yeah, combine like terms. So 18 plus 2y equals 20.
Then subtract 18.
So I get 2y equals 2. So y equals 1. Okay. And so if y equals 1, what does x equal? 4, right? So x equals my 3 plus the 1 I just solved for, so x equals 4. So my answer is y equals 1, x equals 4. First part of my answer. Yes, I think a few more of that makes sense than groans, so that's good. Okay, and then it tells me to plug them back in. See, are these lines parallel? If these lines are parallel, these two angles will equal the same. So 8 times 4
20,
minus
32,
minus 2 equals what?
30
degrees. 25 times 1,
It's 32.
well, is 32 and then minus 2, right?
No, he's talking about,
No,
he's talking about the
25
y.
Oh.
45
plus 7.
Plus 7 is 32. So are these lines parallel? Yeah, no, not parallel.
No.
Yeah, they're close. And this is actually a typo because these lines were already labeled parallel for us, so I'm sorry about that. That was a mistake. Those parallel symbols should not be there when they're asking us to prove it, and it's not true. All right, then next one, solve by substitution. So before I can substitute, first of all, if it didn't say solve by substitution, do you think it'd be easier to do this by elimination or substitution?
Elimination.
Okay, so let's review how to do it with elimination. Elimination means we try to just add the two equations together and eliminate something. So if I multiply this whole equation by, what do I have to multiply it by? 6 or negative 6? Negative 6, right? Because I need that I need the x to turn into positive 12. Okay, and you guys, you can solve any of these equations either way. I'm just showing it this way so you see both options. So I distribute my negative 6 to every single term of this equation. So then I have 12x minus 18y equals negative 18. Did I do my math right? Okay. And then I'm just going to carry down the second equation underneath it. So negative 12x plus 10y equals negative 6. Okay, and then I go ahead and add them together. So the x's cancel out. The y's add together to negative 8y. And the numbers add to negative 24. Alright, and my next step, divide by negative 8. So what does y equal? So y equals 3. How do I find x now? Yeah, so I'm going to take the one with smaller numbers. So negative 2x plus 3 times 3 equals 3. And so that gives me 2x plus 9. What does x equal? X equals 3. You got there before me. Oh, sorry, you guys couldn't see that. Okay. All right, now we plug them back in. So 10 times 3 minus 4 is what? 26. 8 times... No, they're not parallel. All right. Is this better than proofs?
Yes.
Okay.
Yes.
Both of these are
You're not remembering.
Wait, have you added extra credit?